So our third question, we say A contains 1.60 gram of triazonate 5 acid in 250 of solution. B contains 9.0 GDM cube of XHCO3. 25 centimeter cube portions of B required an average of 24.90 of A for complete neutralization. Calculate the concentration of acid in mole per dm cube, concentration of XHCO3 in B in mole per dm cube, molar mass of the B, value of X. So we start with the given as usual. So let's take our given. We have our A for acids and B for our base. We say A contains 1.60 gram. 1.60 gram in 250 cm cube. Remember, this should be for a mass concentration of the acid, which is mass over volume. We'll get there. B contains 9.0 GDM cube, which is the mass term. Let's call it the GDM cube. The unit for GDM cube is mass concentration. Don't forget that too. 25 cm portions of B. Volume of the base, this is 25 cm cube. Required an average of volume of the acid is 24.90 cm cube for complete neutralization ratio. To calculate the concentration of the acid in mole per dm cube, the concentration of the base, and so on and so forth. And the equation of reaction is always given most time. So let's take this out. We're able to get our Ca, our Na, Cb, and Nb. So for the equation of reaction, which is HNO3 plus XHCO3, which gives us our X nitrate plus water plus CO2. So from there we will proceed. Now let's balance it. We have two hydrogen here. We have two hydrogen. We have NO3, we have CO2 plus another will give us CO3. The equation is balanced. So the number of moles of acid and base is 1:1. So that means I have to take this out so that we can proceed to get the other variables required. So question A says concentration of acid in mole per dm cube. Conc of acid in mole per dm cube. Now, there are two ways which we can get the concentration of acid in mole per dm cube. We use the CAVA formula, and we also use mass concentration of our relative molecular mass. So from the acid, we can get our mass concentration from here and the relative molecular mass of the acid. Let's see the name of the acid. Sorry, I didn't put that down. It's triazonate 5 acid, which is HNO3, and this one is XHCO3. So we don't know the X. So let's proceed. In order for us to do this, we use the formula. Molar conc of the acid is equal to mass conc of A over relative molecular mass of A. But we don't know what our mass conc is. So let's come down here and get our mass conc so we can substitute it into the formula. Then let's call this A1. Mass conc of A is equal to mass in gram over volume in dm cube. And this is the mass in gram is 1.60 gram over the volume is 250 divided by 1000 or in dm cube. And this is equals to 1.6 gram over. So I have 250 divided by 1000 is equal to 0.25 dm cube. And the mass con is 1.6 divided by 0.25 is 6.4. So we have 6.4 GDM cube of A. So the GDM cube now is equals to 6.4 GDM cube. So this is the mass concentration of the acid. Now I have gotten that, I can easily put it here and proceed. I have my mass con of A. The relative molecular mass of this, we can also get there. Let's find the relative molecular mass of HNO3. I think it's 63 if I'm mistaken. So, but here we go. HNO3, hydrogen is 1 plus nitrogen is 14 plus oxygen is 16 times 3. 48 plus 10, 58 plus 1, 59 plus 4, 63. So we have 63 gmol. So if I had to put this variable and this into the equation, now this is what we're going to get. I'm taking this out now. So this is equal to, the mass concentration is 6.4 GDM cube over the relative molecular mass is 63 gmol. So I have the molar concentration now to be 6.4 divided by 63 is equals to 0.102. 0.102 mole per dm cube or A. So the molar con of the acid is 0.102 mole per dm cube. So that's our A. The B says concentration of the base in mole per dm cube. So now let's go to the B. Con of B in mole per dm cube is equals to, now concentration of the base, we cannot use the same formula which is mass con over relative molecular mass, because we cannot determine the relative molecular mass of XHCO3. X is unknown. So the only way we can go about that is to use the formula, the CAVA. Remember the two method, which is the other one, the CAVA, because we have gotten our concentration of the acid, we can now look for that of the base. So with that, I say we use CAVA over CBVB is equals to NA over NB. Now we're looking for CB, so CB is equals to CAVA-NB over VBNA. So this is CB is equals to concentration of the acid 0.102, 0.102 mole per dm cube. Volume of the acid is 24.90 cm cube. Number of moles of the base is 1. All over volume of the base is 25 cm cube times number of moles of the acid is 1. So if I take all the cm cubes out, let me come back here. CB here will be 0.102 times 24.9 divided by 25. 0.102. Wow, what a coincidence. CB is now 0.102 approximately mole per dm cube. So I can easily put here 0.102 mole per dm cube of B. Now the next question says molar mass of the base. So let's move on. C says molar mass of the base. Molar mass of B. Now, molar mass of B is equal to the mass count of B. Mass count of B over molar count of B. And this is the mass concentration of the base is 9.0 GDM3 over the molar count of the base is 0.102 mole per dm3. And this is equals to, now, 9 divided by 0.102 is equals to 88.23. 88.23. We're looking for molar mass, G mole. So we've gotten that to be 88.23. Now let's proceed. The next question says the value of X. If we have known the molar mass of X, so let's find out what the value is. Now for us to get a value, let me write that. That's question D. The value of X. To do that, we say HCO3 is equal to the relative molecular mass of B. And X is here plus hydrogen 1 plus carbon 12 plus 16 times 3, 48. Or is equal to the relative molecular mass, which is 88.23. 23 G mole. Okay, G mole. Now we go on. We say 48 plus 13 is equal to 61. X plus 61 is equal to 88.23. X is equal to 88.23 minus 61. X is equal to 88.23, which is 27.23. 27.23. So if you check very well, 27, the atomic mass of the element X is definitely going to be aluminium, because aluminium has what atomic mass of 27. Although they did not ask us for the element, they just say the value of X. So the value is 23. Let's take our fourth question quickly so we can run. Okay, this one says always are given here. A here is given to be HCl, and B is XOH. 30 cm of HCl, so the volume of the acid is 30 cm. Of HCl, of corn 6.4, the GDM cube 6.4 GDM cube, the mass concentration of the acid. Neutralize 25 cm cube, volume of the base is 25 cm cube of an unknown alkali, XOH, whose concentration is, the GDM cube is 4.85 GDM cube. We should calculate the molar mass of XOH. The molar mass of XOH. So here again, we do not know the mass, we do not know the molar count of A or B. So our Ca we don't know, Cb we don't know, number of moles of acid we don't know, number of moles of base we don't know. The question is HCl plus XOH, which will give us HCl plus water. So when we balance this, hydrogen is 2, oxygen is 1, oxygen is 1, X is 1, X is 1, chlorine 1, 1. So it's balanced. Here is 1 and here is 1. So we're able to establish our number of moles of acid and that of base. So the state is aqueous, 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 and liquid. They say we should calculate the molar count of the base. Now, the molar count of B. To get the molar concentration of B means there are two formulas, remember I said. We have that of mass concentration, which is given, over the relative molecular mass, which is this. But we don't know, we cannot determine the relative molecular mass of X over here because X is unknown. And the other formula says CAVA, concentration of the acid, concentration of the base. We don't know that of the acid, we don't know that of the base. So solving this question in this manner becomes almost impossible unless if you remember the application on how to meander your way through. Knowing too well that you have to now, or we have to now, first of all, go to get the concentration of the acid. They didn't ask us, but that's the basic thing to do. You get the molar count of the acid here, then we can now, when we have that, we can now use CAVA to get that of the B. So they wouldn't tell us, they didn't tell us that. They would have been kind enough to say, calculate the molar count of the acid, B, calculate the molar count of the base, but they decided not to tell us that. They want us to think for ourselves, and so we have done so far. So in order to do this molar count of B, we first get the molar count of A. Therefore, the molar count of A, we use this. Molar count of A is equals to mass count of A over relative molecular mass of A. And this is equals to the mass count of A is given to the 6.4 GDM cube over the relative molecular mass of HCl is 36.5 and 6.5 G mole, and that is equals to what we want to get now. 6.4 divided by 36.5, 0.175. This is 0.175 mole per dm cube of A. So now I come back here, 0.175 mole per dm cube. So that is true. Now, I've gotten this. We can now patiently go back to the original question, which says the molar count of the base. So the molar count of B will now be gotten through the formula CAVA over CBVB is equals to NA over NB. I'm looking for CB, so CB is equals to CAVA NB over VBNA. So this is equals to concentration of the acid 0.175 mole per dm cube. And volume of the acid is 30 cm cube. Number of moles of acid is 1 over volume of the base is 25 cm cube times number of moles of the acid is 1. Cm cube will cancel cm cube and we proceed. 0.175 times 30 was to this divided by 25. We have 0.210. CB is equal to 0.210 mole per dm cube. So I come back here, 0.210 mole per dm cube. So I've got my CB. What is next? The relative atomic mass of the element X. We should name the element. Now the relative atomic mass of X, okay, the relative atomic mass of X. For us to do that, we have our XOH is equal to the relative molecular mass of B. And we don't know what the relative molecular mass here is. We have not solved it, so we have to proceed to solve it first. So now, let's get the relative molecular mass first before we come back. Now, the relative molecular mass of B is equal to the mass conc of B over the molar conc of B. This is equal to mass conc of B is 4.85 ggm³. Molar conc of B 0.210 mole per gm³. And when we do that, we have 4.85 divided by 0.210. That is 23.1. So let's call it 23.1 gmol. So now we have our relative molecular mass of B to be 23.1 gmol. So now if we come back to the formula, which is this, we can determine our X. So let me take these ones out now. Now X is given to be unknown plus 16 plus 1 is equal to 23.1. So X plus 17 is equal to 23.1. X is equal to 23.1 minus 17. And X is equal to that. 6.01. So 6.01. So the element in the periodic table that has an atomic mass of 6, hydrogen, helium, lithium. So that is lithium. Now let's solve our last question. We're going to be a little fast with this one. Last question for the day. It says our given A is HCl. It says 28.0 cm³ of hydrochloric acid. Volume of acid is 28.0 cm³ of HCl with 4.1 ggm³. The ggm³, the mass concentration is 4.1 ggm³ of the acid. Neutralize 25 of B. Volume of the base is 25 cm³ of an unknown alkali, YOH. Whose concentration is, the ggm³ is also given here to be 7.0 ggm³. We should calculate the molar conc of YOH. The molar conc of YOH. So we have Ca, Na, Cb not known, and Nb. So from the equation let's balance, we have our HCl plus YOH. This gives us YCl plus water. 2 hydrogen here, 2 hydrogen there, 1 oxygen, 1 oxygen, 1 Cl, 1 Cl. So the number of moles of acid is 1, number of moles of base is 1. Aqueous liquid. Take note. I only need the equation of reaction so that I can proceed further. So they are asking us again to calculate the molar conc of the base. Like I said earlier on, we cannot calculate the molar conc of the base here directly without knowing the molar conc of the acid, because from molar conc we have mass concentration of our relative molecular mass. We cannot determine the relative molecular mass of YOH. So because of that, we have to come down here, get the molar conc of the acid, which is mass conc of our relative molecular mass, which is 36.5. We get the molar conc of the acid, Ca. Then we use the CABA formula to get the B. So that's what we do. So A, let's say, molar conc of B. To do that, we get the molar conc of A first.
Okay.
So the molar conc of A is equals to mass conc of A over relative molecular mass of A. Therefore, mass conc of A is given to be 4.1. So 4.1 GDM cube over the relative molecular mass of A is 36.5 G mole. So this is equals to 4.1 divided by 36.5, 0.112. 0.112 mole per dm cube. So that is our Ca, 0.112 mole per dm cube. Now, the original question said the molar conc of the base. So now we can go back using the molar conc of the base can be gotten using the formula CAVA over CBVB is equals to NA over NB, where CB is equals to CAVANB over VBNA. And this is equals to concentration of the acid is 0.112 mole per dm cube times volume of the acid is 28 cm cube times number of moles of the acid 1 all over volume of the base is 25 cm cube times number of moles of the acid. Okay, yeah, 1. So let me come here. CB is equals to, I now have 0.112 times 28 is equals to this times 1 is the same. Divide by 25 is equal to 0.125 equal to 0.125 mole per dm cube. So 0.125 mole per dm cube. The relative atomic mass of the element Y. So for us to get the relative atomic mass of Y, remember we must get the relative molecular mass of the compound. So before we start that, let me call this my B, the relative molecular mass of B is equals to mass conc of B over molar conc of B. And the mass conc of B is given to be 7.0 GDM cube over the molar conc of B is 0.125 mole per dm cube. And this is equals to 7 divided by 0.125 equals to 56. So I have 56 G mole as the relative molecular mass. Relative molecular mass is 56 G mole. So for us to get the atomic mass of Y, now we proceed. Let's call that C. C, atomic mass of B is equals to the relative molecular mass of B. Here we have YOH is equals to the relative molecular mass is 56 G mole. Alright, this is Y plus 16 plus 117 is 56. Y is 56 minus 17. Y is equals to 39. So if Y is 39, then potassium have an atomic mass of 39. So that is potassium hydroxide. All right, I think no further questions. So I think that's where we're going to stop for the day. Like I said earlier on, our basic knowledge of the formula is very, very important. If you can't remember the formulas, you cannot solve these questions. So you have to get the full knowledge of all the formulas so you'll be able to know how to find your way through, no matter what it is. You know how to pass in a roundabout manner to get what you want. So go back to our second video where we discuss about the formulas, a whole lot of them. Get yourself acquainted with them so that in case you come across these kind of questions where you have to use 2, 3, 4 formulas to solve them, you will not find it difficult. Thank you and have a nice day.